My most popular video by far was about the UFO captures from the main observatory in Kiyv. So in Ukraine, it was great to get some actual good information out of the war. This video was packed with data, tons of nerdy stuff. I was so pumped that people liked it. I went through the initial report from Boris Zhilyaev. He is the astronomer at the main observatory in Kiyv that released this report. Zhilyaev took a lot of heat for his initial paper. It wasn't peer-reviewed yet, and he made a lot of very interesting claims about capturing these UAPs, these phantoms and cosmics that he captured with a camera in the daytime sky. He used Rayleigh scattering to determine the distance, so basically calorimetry, differences in color to determine actual distance to these objects. Galileo lead and astrophysicist Avi Loeb immediately says it was most likely artillery down to Earth limits on unidentified aerial phenomena. He released a paper right away. Okay, I think he just kind of whipped it out and threw it out there, discounting this, saying it's most likely artillery, and the astronomers are obviously wrong on their distance measuring equipment. Noted debunker Mick West chimed in with his own point that it's probably insects or birds. That's the most likely thing for these captures. Well, Boris Zhilyaev did not give up. He wrote 2 more papers that he sent to me in an email. He submitted both those papers that I'm going to go through in this video to the Kinematics and Physics of Celestial Bodies. That's a Ukrainian physics journal. In both these papers, Boris responds to that argument, says it can't be birds and insects. He's captured birds and insects, and the objects turn around, as I'll show you, so they can't be artillery. Pretty amazing stuff. Thanks for being here. Smash that like button. If you do like this content, consider subscribing to get notifications of my future videos. I release at least a video every Friday. And then get backstage access, ad-free videos, as well as Patreon-only exclusive videos at patreon.com/Chris Lado. Let's get to the video. Here's the email from Boris. Dear Mr. Chris Lado, I appreciate your interest in our work. We recorded UAPs from 2018. Unfortunately, UAPs are particular objects. Many people, including scientists, are very skeptical about them. We were told that it could be insects or birds. That was from Mick West, I think the best argument against. We spent a lot of time studying interference, insects, and birds. They show that in this video. We can now say with certainty that UAPs are not insects or birds. We're sending you 2 of our publications concerning UAPs, which are submitted to the Ukrainian journal Kinematics and Physics of Celestial Bodies. I think you as a blogger can adequately present this material. Best regards, Boris Zhilyaev. So interesting right there. He says basically his results could not be accepted by the community because even scientists, many people, including scientists, are skeptical about them. They know now, they can say now with certainty that these UAPs are not insects or birds, so they're capturing something on these cameras. And it can't be artillery because it turns around, as we'll see. So quite interesting. Let's go through it. Okay, so here is the first paper. It's shorter, Unidentified Aerial Phenomena, Properties of Bright Objects. Okay, he breaks it up into bright objects, which are luminous. He calls those cosmics, and then phantoms, which are basically dark. And towards the end, it looks like they are the same objects. Sounds like he argues they're the same objects. The cosmics are outside of the troposphere, and the phantoms are inside the troposphere. Quite interesting. So this is the intro. NASA commissioned a research team to study UAPs. The main astronomical observatory of NAS of Ukraine conducts an independent study of UAP also. For UAP observations, we use 2 meteor stations installed in Kiyv and the Vina Rivka village in the south of the Kiyv region. 2 side-by-side monitoring of the daytime sky led to the detection of 2 luminous objects at an altitude of 620 and 1130 kilometers, moving at a speed of 256 and 78 kilometers per second. Remember, these guys are astronomers. They're going to know to check it against known satellites. Colorimetric analysis showed that the objects are dark. So they go through, they have basically all the math in this relates on how they're determining the temperature, the colorimeter, and the distance, therefore the distance. The size of objects is estimated to be more than 100 meters. The numbers in this are just amazing. The detection of these objects is an experimental fact. Okay, so they're detecting something. They don't know what it is, but they're detecting something. Estimates of their characteristics follow from observational data, and he puts in here the authors do not interpret these objects. Okay, he does give some guesses. Our astronomical work is daytime observations of meteors and space invasions. Okay, space invasions. They're the right guys looking. Unidentified anomalous air and space objects are deeply concealed phenomena. The main feature of the UAP is its extremely high speed. The eye does not fix phenomena lasting less than 1/10 of a second. It takes 4/10 of a second to recognize an event. Ordinary photo and video recordings will also not capture the UAP. To detect UAP, we need to fine-tune the equipment, shutter speed, frame rate, and dynamic range. So this is one of the main arguments here is Boris says that these objects are traveling so fast that we cannot detect them with our systems. And they're also not visible to sunlight, so they don't reflect sunlight. So how can we see them, do you say? That's a good question. The way I understand it is kind of like passive radar ranging is we can't get a radar hit directly from, say, the stealth aircraft, but we can see the stealth aircraft by how it interacts with the surrounding radar energy, right? That's how passive radar works against stealth aircraft, right? Because a stealth aircraft is invisible to radar, but you can still see it with your eyes, correct? So you can be invisible in certain spectrums, but visible in other spectrums, right? We can still see an F-22. Okay, you can see these aircraft. You can still see a B-2. Passive ranging of radar is this idea that you can't get a direct hit back from the aircraft, but you can see it going through the air. It's like in Star Trek. You remember when they saw the stealth Klingon ship by how it changes the background? That's basically the same idea. According to our data, there are two types of UAP, which we conventionally call cosmics and phantoms. We know that cosmics are luminous objects brighter than the background of the sky. Phantoms are dark objects with a contrast, according to our data, from 50% to several percent. So that means that, from what I understand, at 0%, it's invisible, totally invisible. It has an albedo. It doesn't reflect any of the light back, okay? Both types of UAPs exhibit extremely high movement speeds. We're talking up to Mach 60. Their detection is a difficult experimental problem. They are a byproduct of our main astronomical work, daytime observations of meteors and space intrusions. So this is his main work, and he uses this distance measuring technique. For UAP observations, we use two meteor stations installed in Kiyv and in the Vina-Rivka village in the south of the Kiyv region. The distances between the stations is 120 kilometers. The stations are equipped with ASCII 174mm and ASCII 294 Pro cameras and lenses with a focal length of 50 FND 28 millimeters. They also have ASCII 174 cameras set up as well, and ASCII 294 Pro cameras set up with those setups, up to 50 frames per second. Okay, to determine the coordinates of objects, the cameras were installed in the direction of the moon. So here's the results of the first one. So this is a luminous object, and you look here from two cameras. So the first object is in Vina-Rivka, you see here, and then at the same time in Kiyv. So basically, it's a simultaneous capture of this same object. Okay, another capture here. Again, simultaneous capture. So second object, this is in Vina-Rivka, 120 kilometers away. There's the object, right? And then from Kiyv now, we have the object again. So they have the same object. So we can rule out basic mistakes or camera glare. We can rule out the glare effect, if you will, just having two systems there. And this is what they're talking about, the albedo. Okay, this is basically the brightness. So you can mirror the brightness. And what they show is basically the object is there, okay, and it has a similar brightness profile. And now they can use basically math, trigonometry to determine how far away the object is. So you need the size of the object, r is the distance of the object, albedo is sigma, and then beta is the ratio of the brightness of the object to the brightness of the background. This horseshoe looking thing is the solid angle of the pixel. So basically that's how they're determining the range. That's how he's determining the range. So you need object brightness, you need sky background, and you need angle of the pixel. So using that, they're able to determine some basic size possibilities based on the albedo. Okay, so if your albedo less, if it's very low, it's going to be giant. Okay, and if it has an albedo of 0.2, this is 20% contrast, so 20% reflection back. It's going to be 109 meters across. Here they say size estimates seem fantastic, right? Basically, you're saying if it's below 1%, you're 155 meters, approaching 500 meters. The angular size observed gives a geometrical dimension about of 1 kilometer. Okay, so that's huge. Motion blur caused by the rapid movement of an object gives some increase in size. However, the problem does not disappear. Okay, so it's not all up to motion blur. Serious doubts are raised by the fact that these objects are not detected by radar, asteroid observers, and the military. That's the whole point of Avi Loeb saying is this can't be possible, so it's not possible, right? How can you have something that's 100 meters across traveling at that speed and we can't detect it with other means? Like, could there actually be something invisible there? Well, not if you don't think it's possible. They are not seen at night. Okay, he says this is because we can only detect it through their reflection in sunlight. So basically in the atmosphere from reflected light. Even though they don't reflect it, the air around them reflects it, from the way I understand it. It follows that they shine by reflected sunlight. Regular albedo of 0.2 gives dimensions of hundreds of meters. It would seem that nothing prevents their easy detection. Okay, an effective way to assume a very low albedo would make them undetectable to radar and the military. Okay, so this is one way he's talking about to make these things invisible, to be invisible. Albedo less than 0.01 would seem to make them practically black bodies, not reflecting electromagnetic radiation. Avi Loeb's argument is this is not possible. If a thing is there, it has to reflect electromagnetic radiation. Therefore, this is all incorrect, can't be possible. Right? It's not possible because it's not possible. Indeed, a body smaller by an order of magnitude will emit 2 orders of magnitude less and will become invisible. Unfortunately, observations indicate large angular dimensions, and as a consequence, large geometric dimensions too, target 1 kilometer. It is possible to agree on large angular dimensions and theoretical estimates only by accepting extremely low albedo values, less than 1%. This makes them invisible to the radar and the military. Not surprisingly, stealth technology makes aircraft undetectable to radar, but not to the eye. So that's Boris's argument, is that the only way this math works, the only way we can make his math work based on the observed data is that the albedo is very, very low, i.e. invisible. So these things are basically invisible. And he says that's not unheard of. If you look at stealth technology, it's invisible to radar, but you can still see it with the naked eye. It can be shown that objects with anomalously low albedo, less than 1%, behave like a black body. It can be assumed that in the troposphere, they look like phantoms, and outside the troposphere, they look like cosmics. So he says it right there. He's just making a postulation here, even though they said they didn't. He says that it can be assumed that in the troposphere, these objects, whatever they are, look like phantoms. But outside the troposphere, they look like the cosmics. Quite interesting. Okay, here he goes through basic math on albedo. So 0.5 albedo, and this is 0.01 albedo, basically reflects nothing back. Conclusions. Observations were performed with color video cameras in the daytime sky. A special observation technique had developed for detecting and evaluating UAP characteristics. There are 2 types of UAP, conventionally called cosmics and phantoms. Cosmics are luminous objects brighter than the background of the sky. Phantoms are dark objects with contrast from several to about 50%. 2-side observations of UAPs at a base of 120 kilometers with 2 synchronized cameras allow the detection of 2 variable objects at an altitude of 620 and 1130 kilometers, moving at a speed of 256 and 78 kilometers per second. I mean, those are insane numbers. Those are just insane numbers. 78 kilometers per second. It's just insane. Color properties of bright flying objects indicate that objects are perceived as very dark. Albedo less than 0.01 would seem to make them practically black bodies, not reflecting electromagnetic radiation. We can assume that a bright flying object, once in the troposphere, will be visible as a phantom. Okay, wow, that was the first paper and goes through most of the math and most of the arguments. So in the second paper, Unidentified Aerial Phenomena, Properties of Dark Objects, I'm going to go right to just the key points. Daytime sky monitoring in Kiyv with multicolor DSL camera at a rate of 30 frames per second in August, September 2018, and in Vina Rivka with a multicolor CMOS camera in October 2022 revealed several cases of dark objects. The time of their existence is, as a rule, a fraction of a second. These are oval-shaped objects ranging in size from 20 to 100 meters with speeds from 2 to 30 kilometers per second. Estimates of their characteristics follow from observational data. The authors do not interpret these objects. Okay, so these are slightly different, okay? 20 to 100 meters, so not nearly as big, and 2 to 30 kilometers per second, so still quite fast. 30 kilometers a second is Mach 60, so extremely fast. According to our data, there are two types of UAP, which we conventionally call cosmics and phantoms. We note that cosmics are luminous objects, brighter than the background of the sky. Phantoms are dark objects with a contrast, according to our data, from 50% to several percent. Both types of UAPs exhibit extremely high movement speeds. The results of our previous study are published in 2. Phantoms are observed in the troposphere at distances up to 10 to 14 kilometers. We estimate their size from 3 to 12 meters and speeds up to 15 kilometers per second. Phantom shows the color characteristics inherent in an object with zero albedos. Again, that's what using their colorimetry methods. We see an object because it shields radiation due to Rayleigh scattering. An object contrast made it possible to estimate the distance using calorimetric methods. So the paper basically explains that last paragraph. Since the contrast is determined with an error due to the dynamic range of the camera and atmospheric noise, the detection of the phantom is limited to a distance of 10 to 14 kilometers. In particular, this can explain the sudden appearance and disappearance of the phantom. So what this means is the way they had their camera set up, and these things are moving so fast that it's only in range essentially between 10 and 14 kilometers. That's the only time everything aligns so the camera, it's not too far away for the camera to detect, but it's also not too close that the camera can't detect. That's what I understood. So 10 to 14 kilometers is really where they're set up to really capture these. Okay, so this is interesting. They go through the first object. Okay, object 9252 was detected during the sky monitoring on August 24th, 2018 at about 9 a.m. The clear sky was monitored in video mode with a Canon 5D Mark III camera. There is some military equipment going by, but they note this, following characteristics. The moving object was observed for 0.1 seconds. At the beginning, it was at a distance of 8.5 plus or minus 2 kilometers, altitude of 9.6 kilometers. At the beginning, it was 8.5 kilometers away and 9.6 kilometers high. But at the end, it is 13.3 kilometers away at an altitude of 13.6 kilometers and had angular dimensions comparable to the moon. Wow, amazing. Very large. The object moved at a speed of about 96 degrees a second. They estimated it to be about 94 meters across. They use a blinking technology to actually detect, from what I can tell, using that calorimetry methods. So they get a detect here. Basically, something is showing up. And then they can go and look and analyze the actual images. And so this is what they got from this. They used the blinking method, and they're able to outline the trajectory of the object. You see it like turns here. Okay, this is pseudo color. But that's the object there moving. And they seem very open-minded and release all the information here. They say, how did we restore it? So I didn't know this. The operation inverse to convolution is called deconvolution. So they're removing motion blur. Okay, so as you see, these things are moving so fast. Okay, how do you look at what the object actually looks like? It's called deconvolution, and you'll see here it's basically like looks like a tic tac. It does sort of look like a tic tac. Okay, so they explain basically how they do the RGB data. Okay, so this goes through. I am not an astronomer. Okay, so I would ask if you guys, you're astronomers out there, optics experts, can you please let me know? What do you think of this calorimetry method? Is this Rayleigh scattering legit? Could this actually be a possible realistic thing? All right, and this part is good. They go through. Now Boris talks about it's not birds or insects. So how is it not birds and insects? They spent a lot of time, he said. So he goes through an example here at a distance of 1 kilometer with an angular resolution of 1 arc minute. The linear size of the object is 50 centimeters. So he's saying, let's look at birds. Let the characteristic size of the birds be 20 to 10 centimeters. Then the birds at a distance of 400 and 200 meters will look like point objects. At smaller distances, the birds will look like structured objects. Assuming the speed of the birds is 10 meters per second, it is easy to estimate their angular velocity of about 1 and 2 degrees per second. So basically, he's telling Mick West here that you're way out to lunch. It doesn't make any sense. Okay, they would easily tell if it's a bird, and you can see here. Okay, it would have to be so close to actually determine that it's a bird, and if it's further away, it would be moving much, much slower. So he's saying these cannot be birds and they can't be insects. Again, he uses here other ways to explain it. And they do the colorimetry method again to show that birds have a constant RGB method. The color charts of birds with characteristics of a black body with low albedo. Okay, they have even more math to say that. This all comes about to the entire set of data presented, including the values of distances, angular and linear velocities, and color variations along the track, allows us to conclude with high reliability that birds cannot imitate the characteristics of phantoms. Okay. Insects are the primary source of interference in UAP observations. I would tend to agree. They partly shine with reflected solar radiation in proportion to their albedo and shield atmospheric radiation. In practice, insects become invisible at distances greater than 15 meters due to competition with the atmospheric radiation intensity and measurement errors. So great point. So he's saying outside of a certain distance, around 15 meters, you're not going to be able to even see these insects. Can't make them out. Angular resolution too low. So here they have shows figure 15 shows images of several types of insects that can mimic phantoms. Figure 16 shows color maps of insects. The obvious conclusion is that insects are not black bodies. Like birds, they also do not change their color during movement. So very different from the phantoms and cosmics. So Boris basically showed there, I think with a hammer, that it can't be birds or insects. So now let's look at why it couldn't be artillery. Why it can't be artillery as well. Look at Arrival 2. Look at this example. Okay, Arrival 2. Look at that. It turns around. It turns around. Artillery can't do that. Not at that speed. An object appears suddenly at a distance of 11 kilometers and an altitude of about 2 kilometers. Approached at a distance of about 4 kilometers. The object turned around and left. The evolution of the shape of the object in the process of movement is clearly visible. They say, oh, cool. The object was moving at a speed of about 10 kilometers per second. That is Mach 6. Okay, that is 6 nautical miles per second times 60 is 360 nautical miles per minute. So approximates to Mach 36. Mach 36, that's pretty fast. An object at a distance of about 11 kilometers looks like a faint spot against the background of daytime sky, clearly visible to the naked eye as a black object at a distance of about 4 kilometers. That was my question, is how can we see it? But maybe it's invisible to radar and other things, but not the naked eye. Colorimetry of traces of an object allows us to determine its main characteristics: range, height, size, and speed. So those are these next figures here. So based on the calorimetry, they're able to determine the distance is 11 kilometers there based on Rayleigh scattering, again, because in between us is a certain amount of atmosphere. And if we know how much atmosphere it takes to scatter, then you can determine the distance. Interesting here, the shapes too. Okay, in this capture, 612, you can see it clearly here. Phantom visible to the naked eye. Altitudes at the beginning, 2.4 kilometers. At the end, 1.9 kilometers. This is 0.72 seconds. They estimate 79 meters across, plus or minus 5 meters. Okay, arrival number 3. Look at this one again. Turns. Object maneuvers in 0.13 seconds. And arrival number 4. Okay, you have the first image here and then first image there. Okay, so it's basically moving from here and then here. So that was arrival number 4. That was October 15th, 2022 from Vina Rivka. The whole episode took 0.128 seconds. The object's color map gives a distance of about 13.7 kilometers. Speed is 7.2. Mach size is 20 meters. So 60 feet around. Same as a Tic Tac could be. Is this what they're detecting? I mean, just the Tic Tac story is unbelievable. So the data, the evidence coming from that would also be unbelievable by our own accounts. Okay, conclusions. We demonstrate the properties of several phantoms that were observed in Kiyv and the Kiyv region in 2018 to 2022. Phantoms are observed in the troposphere at distances up to 10 to 14 kilometers. We estimate their size from 20 to about 100 meters, speeds up to 30 kilometers per second. All we can say about phantoms is to repeat the famous quote, coming from the part of space that lies outside Earth and its atmosphere, means belonging or relating to the universe. Interesting. And the rest is their math. Wow, thank you to Boris Zhilyaev and his team of astronomers for not giving up, for putting out true data out there. And like I said, the stories from the Tic Tacs are insane. Okay, you can't have contacts go from 80,000 feet into space immediately down to 28,000 feet and hold altitude, going 100 knots, and then go down to surface level. and then back up to 28,000 feet, okay, before our radars can even pick it up. So that data alone is unbelievable. What we're seeing here is more data captures that seem unbelievable. But as Boris showed, we need to start ruling out what it could be. It can't be birds and insects, as Mick West proposed, and it can't be artillery based on these captures, as Avi Loeb proposes. So what are these things? Interesting to see what the kinematics journal comes up with if they allow this to go into their journal. I hope they do. I hope they get good peer review out of it. What do you guys think? Let me know in the comments. Let me know if you have any astronomers out there about that calorimetry method. If you haven't checked out my video on Russia's shootdown, it's my most popular recent video related to Ukraine, where Russia supposedly shot down a UFO, a white ball in the area. Smash that like button if you do like this content, and then subscribe to get notifications of my future videos. You can join the team, patreon.com/Chris Lato, support the channel, and get backstage exclusive content. You can also help by buying UAP Society merch. We should have Lato Files merch coming out soon. That also really helps the channel and the mission. Have a great day. Peace.